In this question we are given g of p is the Fourier transform of f of x, where f of x is equal to 1 by root of modulus of x. We have to find the correct form of g of p. Correct form of Fourier transform of f of x is to be found. Let's do this. G of p is equal to integral minus infinity to plus infinity. F of x is 1 by root of modulus of x times e raised to I px dx. This is equal to integral minus infinity to plus infinity 1 by root of modulus of x times e raised to I px can be written as cos px plus I sin px dx. Now 1 by root of modulus of x is even function times cos px. Cos px is also even function, so this function is even. This is even function. 1 by root of modulus of x times I sin pi x. This is I sin px is odd function because sin is odd function. Now we can use the properties of even and odd functions, which is integral minus infinity to plus infinity f of x dx. This is equal to 2 times integral 0 to infinity f of x dx. If f is even is equal to 0 if f is odd. Because 1 by root of modulus of x times I sin px is odd, it will not contribute anything. We will have g of p is equal to integral 0 to infinity 2 times 1 by root of modulus of x times cos px dx. Now since x is only from 0 to infinity, there is no need to put modulus. We can write 1 by root of x cos px dx. Now there is no need to evaluate the integral completely. We only need to identify the correct form. In the question we are only required to identify the correct form of g of p, and beta is constant here, so we need only proportionality. We need to know what is the proportionality of g of p with p. Is it 1 by 2, is it minus 1 by 2, is it square, whatever it is, we have to find that out. Now as I am only required to understand the proportionality, if I can take this p outside from cosine, then it will be better. So I will put u is equal to px, which implies x is equal to u by p, and dx is equal to 1 by p du. When x equal to 0, u equal to 0. When x equal to infinity, u equal to infinity. Therefore I can write g of p is equal to, now I will write everything in terms of u, integral 2 times integral 0 to infinity 1 by root of x is u by p cos p times x is u by p times dx is 1 by p du. Therefore we have g of p is equal to this p will come upside, root p, there is a 2 here, divided by p. This p, we are also taking this p outside, integral 0 to infinity cos u divided by root u. This p and this p gets cancelled, and inside the cos there will only be u. So we have this thing du. Now this is a definite integral and it will produce a number. It is not depending on p, and we only need the dependence of p. Root p and root p gets cancelled. Therefore we have g of p, 1 root p gets cancelled. G of p is equal to some constant divided by root p. Now the domain of Fourier transform, it runs from minus infinity to plus infinity. Therefore we have to include negative p as well. And if negative comes inside the root, then it is problem. So we will put beta divided by root of modulus of p to include negative values of p as well. Therefore the correct option here is option A.